Space is vast and truly beyond our comprehension. However, every now and then, scientists make a discovery that leaves the entire world speechless. Recently, a team of international experts, known for debunking several black hole discoveries, have found a stellar mass black hole in a neighboring galaxy. Let's dive into the details of scientists discovering an entirely new type of black hole, which is somewhat of a needle in a haystack. First of all, let's talk about the discovery. A team of scientists who are well known for debunking quite a few black hole discoveries have found an astral black hole in the Large Magellanic Cloud, which is a neighboring galaxy to our own. The study leader, Tomer Shinar, said that for the first time, their team got together to report a black hole discovery instead of rejecting one. Furthermore, they found that the star, which gave rise to the black hole, disappeared without any sign of an explosion. Another exciting thing is that the discovery was made with the European Southern Observatory's Very Large Telescope after 6 years of prior observation. Shinar, who started the study in Belgium at KU Leuven, said that they identified a needle in a haystack. Okay, now a lot of other black hole candidates have been proposed in the past, but this team claims that this is the first dormant stellar mass black hole to be detected like this outside our galaxy. Next up, what are stellar mass black holes? These black holes are formed when massive stars reach the end of their lives and then collapse under their own gravity. If we talk about a binary, a system of two stars revolving around each other, this process leaves behind a black hole in an orbit along with a luminous companion star. The black hole is said to be dormant if it doesn't emit high levels of X-ray radiation, which is how black holes are detected in the first place. Co-author Pablo Merchant said that it's incredible that we know of any dormant black holes, given the fact that they're believed to be very common. More on the black hole and VFTS 243. The newly found black hole is at least 9 times the mass of our sun, and what's even more mind-blowing is the fact that it orbits a huge blue star, which has a mass equivalent to the sun. This duo makes up a binary system that has been named VFTS 243. Billions of dormant black holes are expected to exist in every galaxy. However, this is the first unambiguous detection of a dormant stellar mass black hole out of the Milky Way. Another extraordinary thing is that these types of black holes typically form when huge stars run out of the fuel needed to continue nuclear fusion. Next, the end of the fusion also ends the outward pressure that supports the star against complete gravitational collapse. The core collapse that follows this process is accompanied by a cosmic explosion called a supernova. This supernova blows away the star's outer layers. Dormant holes are hard to spot as they don't really interact with their surroundings. Julia Bodensteiner, a research fellow at ESO in Germany, said that for 2 years they have been looking for such black hole binary systems. She also said that the VFTS 243 has been the most promising candidate up till now. The collaboration searched nearly 1,000 massive stars in the Tarantula Nebula region of the Large Magellanic Cloud to find the VFTS 243. Shinar was also skeptical about this discovery, as being someone who has debunked potential black holes in the past. After some doubts, El Bardi, who is also a co-author of this study, said that he couldn't find a plausible explanation for the data that didn't involve a black hole. Let's talk about the Black Hole Police. This team is nicknamed the Black Hole Police, and this discovery may come as something of a surprise to the astronomy community. This team works on disproving the discovery of black holes rather than confirming them. Now does it make sense why they are called the Black Hole Police? For each of the stars, the team analyzed its spectrum, which measures how much light a star emits at certain wavelengths. The team actively encourages scrutiny and hopes that their work, which is published in Nature Astronomy, will enable the discovery of more stellar mass black holes, which orbit massive stars. El Badri concluded that they certainly expect others in the field to carefully make their analysis and to try to come up with alternative models. He also said that this was a super exciting project to be involved in. If you're interested in reading more about the team's findings, you can check out the paper published on July 18th in the journal Nature Astronomy. Also, for those who don't know, Nature Astronomy is a scientific journal which publishes research and reviews of the highest quality in areas like astronomy and astrophysics. Now, on to some other news. Teledyne releases large array camera for astronomy. Teledyne has released a large array camera to help astronomers image deeper into space. A conference called the SPI Astronomical Telescopes and Instrumentation Conference was held, and this camera was shown over there. The Cosmos camera has an 81 by 81 millimeter imaging area and uses the Teledyne Lacera technology. If you don't know, this technology involves a large area CMOS image sensor. The sensor is backside lit and offers a sub-electron read noise and a more than 90% peak quantum efficiency. It's designed for astronomy applications such as low orbital tracking, time domain astronomy, and exoplanet characterization. These designs have a parallel readout architecture for high image rates, and the charge-to-voltage conversion takes place at each individual pixel. This allows readout nodes on every column of the sensor to operate simultaneously. This is truly a fascinating invention in the world of astronomy. Also, interestingly, Teledyne has delivered imaging solutions for the James Webb Space Telescope and many other projects as well. And now, a new telescope detects dead suns colliding. For the first time, astronomers have detected the smashing together of dead suns, known as neutron stars, thanks to an all-new telescope. The collisions of neutron stars are key to our understanding of the universe. These neutron stars are thought to have created heavy metals that formed stars and planets like our own billions of years ago. Now, the light from the crashes is only visible for a couple of nights, so the telescope must instantly race to locate them. One of these collisions was observed in 2017, but astronomers largely came across it by luck. A professor also said that when a really good detection comes along, it's all hands on deck to make the most of it. If this wasn't enough to blow your mind, neutron stars are so heavy that a small teaspoon of their material weighs 4 billion tons. The telescope is situated on a mountain peak, which is home to a dozen instruments of all shapes and sizes, and each of them studies a different phenomenon. We might think that these explosions are very easy to detect, as they must be energetic and luminous. However, astrophysicists have to search through 100 million stars for the object that they're interested in, as the object disappears within 2 days, and they have to do their study very rapidly. Traditional astronomy is just being lucky, and now scientists aren't hoping for any new discoveries involving this. So let's just see what the universe holds and how we'll be able to uncover it. Lastly, let's talk about how AI is changing astronomy. We're all familiar with the terms artificial intelligence and machine learning, as they're thrown together. However, they are both different things. Let's talk about their relationship with astronomy. One area of astronomy where artificial intelligence has made an impact is in the search for exoplanets. The most productive method with current technology usually involves studying the variation of a star's brightness over time. A phenomenon called gravitational microlensing can cause a spike in a star's brightness when the exoplanet's gravity acts as a lens and magnifies a more distant star. Astronomers have also been able to develop ML-based models that can outperform humans in the search for exoplanets. They have done this using the huge libraries of observed light curves. AI can do much more than this. Are you aware that it can also lead astronomers to new insights and how they work? A team of researchers reported that ML algorithms had helped them discover and develop more understanding of the exoplanet microlensing and how their configuration with the star may vary. According to astronomers, it's also possible that ML and AI will help them identify which planets might be habitable. Many ML models are trained in a way that they differentiate between data. However, others are also intended to produce new data. These models are a subset of AI techniques that go on to create artificial data products. These include images, which are based on some underlying understanding of the data used to train it. Obviously, in a broader perspective, AI is primed to make discoveries that we can't possibly predict, but we'll have to wait for that. That's a wrap for this video. What are your thoughts on scientists discovering an entirely new type of black hole and other related news? Let us know in the comments below. Make sure you give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.